Okay, so I guess we have everything set that wasn't really set before. So I have my speaker notes. I have my beautiful background, which is very reddish pinkish, which is actually the official color of the RChain logo, which is why I picked it, to make it very in your face. No, I'm tired. I don't even want to tell you about it. I guess you are tired too. So I chose this to communicate that I'm trying to do something very visual here. I'm not going to bore you with, well, there will be code, but it will be colored, so it will be kind of enjoyable. That's the idea of this talk. So I'd say we just jump right in. So you already know that Rholang is pretty awesome, right? It's inherently concurrent, it's asynchronous, it works with processes, which means that all computation actually happens through message passing, which is bloody awesome, right? But I think in the talk right before this one, you have seen a few smart contracts, and maybe you felt like this. Maybe you had a brain knot, maybe you had a brain hemorrhage, maybe you need to see a professional, medical professional. I definitely felt that way. I mean, like Rinke, I got in 6 weeks ago, but Rinke has a lot more time on his hands than I do. So what I was looking for really was a way to absorb a smart contract in a much better way than just staring at it, which is actually currently the state of the art when it comes to RChain smart contracts. Stop laughing, I'm trying to be serious here. And I did some digging, and last year at the Ethereum DEF CON in Mexico, Greg Meredith, I think you know that he's the inventor of Rholang, he came up with a way to visualize smart contracts, and I actually drew upon that and started going through the tutorial smart contracts and visualizing them in the same way. And that's what I will show you today. So, short revision. We have channels, we have processes, and we have private channels. Those are kind of the most important things you should kind of keep in mind for the rest of the evening. We know that we can get a channel from a process by quoting it, easy enough, and that channels serve the purpose of passing messages. Of course, also they serve the purpose of having messages read from them, but this is another thing. Processes are what we send over channels in Rholang. And also what we can get a process from a channel by dereferencing it using the asterisk operator. Private channels are a very, very interesting thing. I'm not sure if you heard about it because I wasn't present during the previous talk. They're private, so access to anything contained, sorry, my mistake. They're private unless you send them to another process, so the process can access them. Otherwise, only stuff in the lexical scope of the private channel actually can access stuff on the private channel. The building blocks are pretty simple. So this is a channel, and it will be visualized by two, well, I don't want to call them nodes, but let's call them nodes that contain the name of the channel, and for ease of making it visible, a vertical or slanted pipe. Outside of that, we have processes, which will be made visible by a rectangle with a gray border and the process description with the parameters. Oops, that should have been removed. Ignore. And well, I already told you about coding and uncoding of processes and names. Last but not least, the two most important activities: sending a process over a channel and listening for a message on a certain channel. Those are the things that I have visualized in this way. Essentially, this is sending V over the channel Z, and if we visualize the channel in this way, this is the visualization of essentially just sending V over the channel. This is pretty simple. For listening for a specific pattern, W, on a channel Y, we have the for construction, and this is essentially also. This is not a process. Don't make the mistake I made. This gray border here does not symbolize a process. It's just a symbol for that is easily understood within the context of a smart contract. When you have several of these large boxes next to one another, it's a replacement for the pipe expression, which just says that two things are happening in parallel. On the next slide, when we have several of these, you will kind of see what I mean with that. Another thing that no, that's actually it. All right, simple examples. Hello world and receiving names. If you've actually studied the developer tutorial before, you will know what these are. I wanted to actually make it the second half of the talk, a complex smart contract, but I realized that a smart contract that essentially showcases all the capabilities of Rholang right now I either have the smart contract on the slides or I have the visualization on the slides. I cannot have both unless I have two projectors, so I kind of cut that out. Let's jump into the Hello World contract. What we have at the beginning, the outermost box, is the creation of the Hello World channel. We use the new in keywords to make this a private channel, so any other process that would like to access this can only access this if it is within the lexical scope of the Hello World channel. And if you follow the lines from the Hello World, you see that essentially here is the channel goes into this contract, the channel is also accessed here, and we have two input events. We have Hello World and the sending of the processified my channel. And like I said before, we have one gray box here for this contract and one gray box here for the construction of the new channel. So these two happen in parallel. And I think this is actually a very simple case because you have only nesting of one level. But at least for me, when I look at this, I immediately see, okay, I have this happening in parallel. This is in the lexical scope of the outermost box. And if I didn't even see the code, I could potentially write this down by hand on paper. So I'm not sure what's faster for you to process. For me, at least, it would be an image like this. When we make it a little bit more complicated, sorry, this is another, yeah, actually I will explain the functionality of this contract unless this happened in the talk before. Can you tell me if you went into the Hello World contract before?
It's like different ones, so might be worth reading.
Okay. Well, where do I start? Because I'm already one slide advanced. Should I go back? No, okay. Let's be quite literal here. So within the code, you see that we define this channel here. We define it as a private channel, and then we have two things happening in parallel. We create a contract Hello World with the return channel, and we create a new private channel that sends onto the Hello World channel the message my channel, but the message is essentially just a channel that is turned into a process. What purpose does this actually serve? Because in a typical Hello World example, you kind of output Hello World. What we achieve here is essentially that we have a way to trigger the Hello World contract, which is contained here, and we do this by sending the my channel to the Hello World to the Hello World channel, which then invokes the contract. And this is kind of this is it essentially. Let's go to the more complex sample. It's a little bit more complex than that. Let's start with the outside again. We have another private channel, which we call Hello Again at this time. Within that, we have a contract Hello Again, which also, a contract always takes a parameter, but in this case, instead of actually acting upon the parameter, we throw it away using the underscore wildcard, which means that whatever input you have, you give to the contract, when you invoke it, it's just nulled. And within that contract, we have two more things. We create another private channel, which is called the chan, for visibility. And we also have another for statement, which reads a specific pattern from the channel. And once this pattern is read from the channel, it would normally act, it would normally turn into execute what's in the body of the for expression. Right now, we have a nil, a stop process within the body of the for expression, but normally when we receive something on the channel, we would act upon it. I wanted to go a little bit more into this expression here with the name pattern. So add text is essentially a pattern which means that it's looking for a specific for a process on the channel chan, and when it detects this, it essentially receives this as a name, because you can only receive names on a channel, quotes this, so interprets this as a process, and binds this to the free variable text. So now we can use this process under the moniker text. Pretty easy. You can already imagine if we had actually something more complex in terms of processing, we would already run out of space here. So this is kind of the problem we run into when using this type of visualization. What I'm really looking for at some point in the future is a way to generate these visualizations from these contracts themselves, because what we're doing here, it's not really complicated. And it would be great to actually automate this, but that's a lot of work, especially when you kind of think how you want to put this on one single page. And this is something that I haven't really solved yet. I don't know how to go about that, but I think that is something that would be quite valuable. Even finding a little bit cleaner, how should I say, presentation form than this. I have experimented with different ones. This is pretty close to what Greg proposed last year. But the solutions that I found to visualizing the relationships between the processes, the channels, and the contracts, it's not really that easy to visualize unless you go three-dimensional, but then it gets really complicated with doing this easily and quickly. I would like to wrap up to essentially which is already what I said. When you use a visualization like this, you can easily see what is concurrent, which process is concurrent to which process. You can also see which channel is visible, how deep, and how far its scope goes. And if you have a lot of inputs, you can also see how the information flows through the entirety of the contract. Further down the road, this is what I was hinting at, access relationships. So when you have a more complex smart contract where you have variables, where you have getters and setters, and you want to kind of regulate which parts of your bigger smart contract have access to these getter and setter functions, you need to kind of also visualize how this access would look like. Which parts of the smart contract have what kind of access to which other parts of the smart contract. And this is definitely something that I'm going to be working on next. And well, essentially I would like to hear some feedback from you, because this is a work in progress, really. And I'm not sure if this type of visualization actually makes stuff easier. So that's what I would like to know. There's a question here.
Everyone has seen the mic? I just asked a question. You're fine. Okay.
Yeah.
And we have also like 15 more minutes until Greg dials in, so we can take our time.
Okay, two questions, or maybe the first one is more an observation. The gray rectangle, maybe we should just interpret it as boundary and not as process and something more. I think it is more appropriate to call it boundary. And the second thing is Hello World, my channel. Can you go back?
You mean this?
Yeah. Why is it necessary to send to my channel?
It's not strict. It's in this case, you know, if you exclude this pipe and this entire part here, all you would have is just this small smart contract. But then again, what would be invoking the smart contract? You need something to actually trigger the execution of this. And this happens by sending the process with the asterisk my channel to the hello world channel, which then executes.
You could also send Neil, right?
You could.
Okay.
I mean, if you want to.
So this is
example, as Hello World always is an example of something bigger. So here, for example, you're sending my channel on Hello World, and you can actually see that contact Hello World and then return. It means that my channel, which you're passing in there as some new channel, will turn into a result. So actually there, return dash hello world, it means we're sending not on return, because return doesn't mean anything, but return gets replaced by my channel, which you generated as a private channel in line 5. Do you still follow me? Yeah? And here you're doing nothing else than just printing or sending hello worlds to this channel, and that's it. But what you can also do, you can, after you print it, after you send something in hello world, no, not on hello world, on my channel, you can also have another process, which is afterwards listening on something getting on my channel, or you can trigger a continuation, which happens after I get something on hello world, then send something to, I don't know, hello Donald Trump or whatever, or I mean, that's the principle in RChain. You can send and receive, but the send and receive is not just sending and receiving, but once you receive something, you trigger a continuation. And in this continuation, the whatever was returned gets replaced by my channel, and that's where the computation happens. So, I mean, this is really complex. I understand that, and but you have to wrap your mind around it. Yeah. So, sorry if it took too long.
No worries. Thanks for the comment. David, I have 2 questions for you. The first one is, why you were starting with wrapping your head around the visualization. Do you think that it's applicable for the future, that we will be able to write smart contracts just either via visual interface?
So there are several projects that are trying to achieve something similar, completely detached from blockchain. Just, you know, putting blocks together, compiling code out of that. Potentially we could. I mean, I'm not the expert on this. I mean, there are people who have been doing stuff like that, going from a visual representation to a structured representation to actual code. I'm sure this will be somewhere down there in 5 years, in 10 years. This is something that actually needs to happen for society as a whole to kind of approach technology in a more open way, not just always delegating to the nerds, the geeks, whatever. Actually, in the 70s and 80s, when it was kind of the first wave of, whoa, programming can make stuff happen, there was this kind of meme spread around that people who were in a position of that would decide or influence things in an enterprise that would depend, let's say IBM, that would depend on code, they would think that any human can be taught to code. This has been kind of debunked by experience over the next 2-3 decades. But I think if we find the right way of communicating code, we can definitely expand the base of people who are able to program something, and even redefine what programming means, because programming to me means you want to make something happen, you think about it, and you just make it happen in a structured way. And the tools we have today just make it kind of hard to think in a structured way. And when you look at Rholang, it makes it 1 order of magnitude harder. Let's put it that way. And yes, I would definitely be very happy to see a visual code composition tool happen for Rholang. That would be great.
I mean, we see developments in augmented reality and virtual reality. So, I mean, we will see definitely the way that we can have 3D visualization of whatever, right? We already see that in the construction space. Mm-hmm. When you were thinking about having the 3rd dimension on the visualization side, would you think that this is helpful for getting that complexity visualized?
I think yes, but not using this kind of visualization. I mean, if you imagine this in 3 dimensions, it becomes a maze that you have to walk through. So I'm leaning towards finding a new representation for that. I don't know what it might be. I'm not into VR, AR at all. I don't have time for that, which I would love to, but I don't. But this could be an incredible tool for education, really. I mean, if this becomes a standard of computation in the future, which I think is quite likely, because right now we don't have anything like this that is kind of pursued with this tenacity as we do. Yeah, visualizing it in 3 dimensions would work.
Thanks. Are there more questions?
I wanted to actually get back to the question at the beginning, because what I tried to convey at the beginning, I guess I was too short on breath, was that a gray box is not always a process. It is indeed a boundary to just define the scope. So, I mean, of course, here we define the scope of the new in, here we define the scope of the contract, but essentially here we have a process. I mean, now it's the stop process, so it's kind of boring. But on the third slide, we actually saw a process that would have taken inputs and arguments. Just saying.
Maybe you should have like a dotted rectangle or something sort of process so that most often if you're using it as a boundary, it can be just a gray line.
I actually tried that, but then again, when you have several boxes right next to one another, and I mean, this is 1, 2, 4, 5. So this is not very complex, but when you have imagine you have a huge contract, and in parallel, concurrently to that, you have another contract of the same complexity happening. You will get lost. I mean, you might say, okay, maybe that's when we switch to a 3-dimensional point of view, but maybe in a year, maybe for the next big meetup, wherever it's going to be, we might have something like that.
Just maybe a suggestion, or I was wondering, have you tried coloring for the visualization with semantics instead of the actual grammar? So you color each variable, each different variable a different color? Because the syntax is so lightweight, there's not that many different things. I think it's
I haven't tried it, but it's definitely something I might want to look into.
Variable.
Yeah.
Okay.
Thanks for the suggestion, actually.
Have you thought about maybe having a Prezi style representation of this thing? Because now you have the nil process, but what if you could zoom into that?
Yeah,
In that kind of, yeah.
I absolutely understand what you mean.
It would get difficult with the channels
Crazy.
because they go upwards, but you could like hide them in a kind of way. So you don't mention them, but if you zoom in, you get to understand it. Like the whole
I
code
see what
base.
you mean. I haven't used Prezi. I only was vaguely aware of the concept, but now that I've never used it.
Well, I'm referring to the zooming in function only. So
Okay, I'm not sure if Google Slides has this, but this is actually a very good suggestion.
Let's try it with Prezi. I love that idea. It's awesome.
And support a Hungarian startup at the same time. Okay, no, actually, that's a good suggestion. I wish I could write this down.
With the order, how the questions came in.
So just as a proposal, or my point of view on that is, rather than having a 3-dimensional visualization of that, I would rather see forcing the developer to use the compositionality and modularity and keep the program in itself on one page. And then have the option to click on, for example, a process, and then a new window opens that describes this process.
Oh, it would be great if we had the tools for that.
Thanks for the suggestion. So more questions, please raise your hand.
And there was
if
a
you have
direct
questions.
reply right next to you.
Maybe I'll suggest some more general questions. We
Okay.
might accept them.
So this was a reply, right? And I'm sorry.
what you were talking about in 3 dimensionals, visualizing in 3 dimensions. Essentially, this Prezi approach is doing the same thing, but in slices.
Yeah, essentially, I mean, if you want to call it 2.5-dimensional or just sliced, it is the same thing in the end. You're absolutely right.
And it's way easier than looking at a 3-dimensional picture.
Depends on your
Well,
brain, right?
True, true.
Let me go to the questions. So you had a question, right?
About the Prezi ID. It kind of already exists with different frameworks. So you have TensorFlow, a machine learning framework, that has an extensive tensor board where you can zoom in on parts of the computation graph to view kind of like this, but then with expansions. So you can hide the unimportant
Yeah, so
details.
essentially it's like exploring a
Right.
small graph that has content, and whenever you
Exactly.
just get deeper into the graph, you see more detail. That would be great. That would be great. I mean, if you're
Maybe-
working in this, let's just meet every second weekend in the month, and we can actually make this happen, because I definitely,
Well,
I will run out of time if I stop
Yeah,
doing
sure.
this.
Next question, maybe.
No, we still have 5 more minutes.
So we have 5 more minutes. And just to let you know, as a reminder for everyone, these are all co-op members which just joined some weeks ago. So if you want to participate and contribute, please let us know. Any more questions from your side? And they can also be non-technical. We have 5 minutes more to go before we tune in with Craig.
So I have 2 questions, sort of. Like, do you know if there are like existing work made on like visualizing functional languages, because they have kind of the same basis into the mathematics and pi calculus, or yeah, like this kind of stuff?
It sounds like a reasonable expectation, but I actually don't know of anything. Do you maybe know if there are frameworks that help visualize functional languages? Have you heard of any? I'm not going. I love LaTeX, but I'm not going to comment.
What is with Statebox?
Well, Statebox, that's indeed. Yeah.
Is it Dutch?
It's a very pity that they are not here, by the way. Just for the record, Statebox guys.
Yeah, I think one of them is outside, but maybe I was seeing ghosts. Second question.
Second question is a tough one because it's highly subjective.
Yeah, I think one of them is outside. Maybe I was. Excellent. So, bring it.
What's your favorite color?
My favorite color. So, the chosen one, or the one that is actually my favorite color.
If you think about a blockchain or something.
When you think about blockchain. Oh, yeah.
What about RChain?
Favorite color. And this is a very tough question. It's at the same time subjective, but it's also like a trick question.
Well, so you started by criticizing the color, didn't you?
My favorite color is definitely black, because black isn't the color, and that way I'm kind of showing that I'm a deviant. There you go. No, honestly, my favorite color personally is blue, but I look good in green. I don't think the RChain current official logo color is ever going to be my favorite, but I used it because it kind of was it was like an interrobang in your face. That was the reason. Thank you. Guys, we still have a few minutes.
Yes. Yeah, just continue.
More questions.
Just a general RChain question. I've become member of the COOP. What can I do now?
Well, as a co-op member, you can let me. The one thing that I think is quite important, but not really well working, is participating in the bounty system, which means RChain has a lot of issues, like every other blockchain project, that are bountied, so you can get a bounty for solving them. And this is something that you can easily do when you're a co-op member. I will not explain the process because they're fixing it. They're fixing it. But essentially, you need approval from other co-op members for your contribution towards a bounty. This is kind of reviewed by others, and then the bounty will be released to you. That's one thing you can do. Another thing...
Bounties are non-technical then? You don't mean
both
bounties.
technical, non-technical and technical. And you can also propose your own bounties. If they are approved, essentially you can kind of create tasks and solve those tasks, or have other people solve those tasks.
But why would there be a threshold for open source contributions? I mean,
do you
why
mean
do I need to, I mean, becoming COOP member is a threshold. I need, for example, I need to identify myself. I might not want to. And so if I just look at the open source code, I want to contribute, why do I need to be a COOP member or co-op member?
Actually, I haven't contributed code yet. Do you know, Philip, if it's necessary to be a co-op member to be able to have a pull request? No.
No, I don't think so. Actually, you can, without being a member, without becoming a member.
1 second.
I think it's only for
You can contribute without becoming a member, but to participate in the bounty system, you need to be part of the co-op with the identity and all that, because for US taxation purposes and accounting reasons, they need to be able to have that ability to say, here is who we paid how much, especially because if you are paid beyond a certain amount, then it needs to be recorded and reported. So
bounty implies reward, that's why. Okay, right.
Yeah, I mean, I thought you knew that, sorry. I mean, in general about bounties.
I mean, I'm new here, so I'm asking that question.
You can also join and contribute to the members Discord. So there's like a chat that you can only chat on if you're a target
Yeah, and also there's the possibility to engage within the RChain co-op, so a cooperative. Is the model of the organizational structure of RChain. And as a member, you can participate in the governance process, which is ongoing. And there's still certain things that needs to be improved. And yeah, and a lot of tasks are given out on the bounty system.
And another thing that I'm not sure if it was mentioned, RChain is in the process of creating a European co-op, so not just the American one, but also a European one. And in the near future, this might also be another option for you. I'm not sure what kind of KYC or what other rules they will employ, but if you want to kind of know about that and maybe influence that, becoming a co-op member or being a co-op member now is also a possibility. You get inside, you can actually see what's going to happen.
And like it's defined. You can go to the website. Like a co-op member has certain rights. One of these rights is, I think, to call a general meeting of other co-op members. One of the rights is to hire or fire board members. It's not a company, but it's as a co-op member you have some rights, and you can only access these rights actually being a co-op member. So. But that's a very good question. I think Mike is here already. Greg might come.
Wait a minute.
So let's have some more questions
I was being watched.
for now. Yes.
Can you explain more this? As a co-op member, I have the right to make an assembly, as you said before. Can you explain this, how this works? So, because there are a lot of members.
So how it works in practice, I'm not completely sure. Oh, you do. Okay, good.
In order to request or to have a special membership meeting, you need the quorum of 10%. So you need 10% of the membership to agree that there should be a specific membership meeting on a certain topic, and then yeah, this is gonna take place.
Okay, so Greg, Mike, do you hear us?
Yes. I can hear you. Can you hear me?
Yes, we can hear you. But 1 second, we put up this. Okay, can you do this? Because otherwise, I'm afraid. Oh, yeah.
Please keep talking, Greg. I need to find the right channel.
Yeah.
You want me to talk or just Greg? Talking now. How is that? Is that good? Okay. There you go. Okay. It's probably not going to work right now. Okay. Mike, after you.
I am the CTO of Pyrofex. Pyrofex was hired by RChain to build their cryptocurrency platform. Greg and I have been working together for about a decade on type theory. So it was fairly natural that we would work together on designing the platform and getting it built.
Cool. Yeah. Yeah, I've really enjoyed working with Mike over the last decade or so. I'm Greg Meredith. Currently, I'm the president of RChain Cooperative. Um, RChain is built using some mathematics that I discovered and invented. I don't know what you want to say. And it turns out that that just happened to, by accident or fortune, line up very, very well with the market requirements for the blockchain. Okay. Yeah, sure. Thanks for asking. Uh, I was initially working on, well, it's a long story. I'm going to tell you just a tiny piece of it. I had been working on a platform for a decentralized social network, and that had come about because I had an entrepreneur approach me and say that he was very, very concerned about the sort of privacy imbalance coupled with the economic imbalance. And he felt that the that providing some kind of decentralized solution for that would make sense. And at the time, I was building a platform that that was essentially a platform for doing biology, decentralized approach to large-scale biology. And we realized that it could be appropriated to solve this problem. So we began working on that. And then I said, so yeah, but how are we going to make this sustainable, right? What's the click to pay event, and how do we, because we can't use ads, that's not going to work. And how do we make that solution be decentralized? And at that point, I realized, well, we needed this decentralized micropayment solution, and I was hoping desperately not to have to build that too. And I ended up, doing a deep dive on the proof of work and the Bitcoin blockchain and Ethereum and their approach. And eventually, I concluded that neither of those approaches were going to be scalable. And realized what were the pieces that needed to make it scalable. One was a revamping of the economically secure, decentralized, distributed, leaderless consensus algorithm, and the other was making sure that what one stored was a concurrent execution, a concurrent VM. And since we had all those pieces, either in flight or already in hand, it made sense to start just rebuilding that. And the truth is that the vast majority of the efforts in the space that have made progress have taken control of the blockchain technology, waiting for someone else to come along with a good scalable blockchain technology has simply not been a viable approach in the market at this point. Hopefully that makes sense. I'm here in Iceland, and we're in the middle of a video shoot, so I'm kind of doing this multitasking here, but hopefully that made sense. Oh yeah, absolutely. We want. I mean, the situation is all hands on deck, right? I mean, the fact is we need a decentralized platform because we have so much to do. Um, the 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 coming changes with respect to the environment are going to be very big, and they're going to require coordination at a scope and scale that we've never experienced before. and and so really, it is all hands on deck. So we need as many people engaged and working on the platform as possible. So really, I'm excited to see that there's so many people engaged. Sure. Actually, I would love to stick around and listen to the developer questions. Yeah.
Well, I am particularly excited by it. When I started working with Greg and learning about his special K framework, um, which was some stuff that we were working on with that entrepreneur, uh, we found that it could do all of the major publication subscription models. So you can do push, pull, messaging, broadcast, selection, pub sub, all of those, NoSQL, all of those styles of communicating data to clients were possible in this framework. So that by itself was pretty cool. Then the type theory came in, and in Scala, we've got structural typing where you can say, I want something, an object that has a method with this signature on it. In Rholang, you can not only say things like that, you can say, I want a program with this structure. So you can characterize implementation details as well as mere data interfaces. As we get to behavioral types in Venus, we intend to be able to say, I need an algorithm that runs in n log n time for this, with this signature, and has these preconditions and postconditions. So whereas in Hugel, you can now search for functions that go from a list of integers to a list of integers, but you'll get the identity function as well as reverse, as well as sort, as well as scramble. All of those are potential solutions of that type-based query. But as we add the structural and behavioral types, we'll be able to make much finer grained queries that say a lot more about what we're looking for. And given a database of code, some kind of repository of code, that provides a new way to monetize open source, that code authors can provide their code and say, I'm willing to let this code be linked in for a fee. And then anyone who wants a particular behavior just has to code up the type, not the entire program, and it'll go find the program that'll solve that for them. Greg was talking about biological approaches. If you can characterize the behavior using a behavioral type of processes that are describing biological processes, that is computational processes that are representing biological ones, then you can issue queries for small molecules that have a particular effect in a biological regime, and so search for cures for diseases and so forth using this kind of language. Now, we're not claiming that the search algorithm is efficient or easy to implement or is going to be done in polynomial time or anything. It just is the fact that now this kind of query becomes possible to state, and then we can work on figuring out which queries are efficient and useful and so on. So all of this stuff taken together, combined with the fact that the derivatives market in the US is something like $250 billion, and smart contracts are either currencies or derivatives, means there's a lot of exciting stuff going on in this space. Yes, so since the last developer conference, we've made some more changes with respect to the way namespaces work and so on. The problem is that we found a trade-off between, let's see, assurance and distributed computation. So in Ethereum, every computer is a copy of the same state. You get no performance benefit by putting it on more computers, because every computer has to simulate the entire thing. If you split up the work so that different computers are working on different things, then they are no longer validating each other's work because they don't have the right inputs. So there's this trade-off between how much am I checking the other guy's work to make sure that it all went well, and how much can we split up the problem among lots of different computers. So at the moment, we have a sort of two-level plan where essentially you have lots of different copies of RChain blockchains that are all being clients of each other. And you have to trust these other blockchains to some extent, because they are doing work that you are not. And so if you want information from them, you just trust that they are giving it to you. Now you can query lots of parts of that network and get many different computers to tell you the same thing, but you're not validating that they have come to the answer correctly. So that's the fundamental trade-off that we're trying to work with in our scaling approach. I can speak to a little of that. Right now, Ethereum is getting approximately 10 transactions a second, and for that is paying the energy cost of the entire nation of Ireland. Because we have no hard problems to solve, it will be enormously faster and enormously cheaper energy-wise. Essentially, the proof of work algorithm prevents you from double spending, whereas proof of stake algorithm merely punishes you for double spending. So it's an after the fact rather than before the fact thing. And so if it's detected that there's an equivocation, you simply lose your bond, as opposed to staking the hardware up front. You stake money that can then be revoked. Not at all. The tuple space itself is language agnostic. Today I was actually looking at the potential of putting JavaScript on the RChain tuple space. The language Rholang is going to change fairly significantly towards Venus. We intend to add a purely functional sublanguage. We intend to have synchronous continuation. So at the moment, the only continuation of a send is nil. Whereas the fact that we can detect that a message has been received in the tuple space means that we can have a continuation after send is acknowledged there, that the block has finalized. So now when we're communicating between blockchains, there's the opportunity for purely asynchronous communication. But within a single one of these blockchains, a single namespace, the communication can be synchronous. Our intent for Mercury is that it be a proof of concept, that we learn from it, and then that it would continue to run as a small part of the Venus network. And we would encourage people to transition away from it. We'll be adding behavioral types, as I mentioned before, to the Venus language. It will grant much more security to the contracts by using behavioral types when you're writing. So yeah, we expect the language to continue to develop and grow, but that won't cause a problem because the tuple space is language agnostic. So I heard two different questions there. One was about whether we could do a Facebook style thing, and one was whether we would implement an Ethereum node in Rholang. We intend to have a notion of an oracle, which allows you to do HTTP fetching. Now, of course, there are lots of different approaches to that. Perhaps if this HTTP fetch is side effecting, you only want it to happen once. And so then you would elect a particular node to do the fetch on your behalf. There'd be no way to verify that it returned the right thing. If it's not side effecting, then perhaps you elect a subset of validators to all make the same request and verify that the result is the same before continuing. But we do intend to provide that ability. And of course, intend to expose the state of the blockchain in a web-friendly way so that people can write dApps that have a web component. So the Facebook style thing seems eminently doable. I don't know that you would want to write an Ethereum node in Rholang. That seems like you're layering one blockchain on top of another one, causing these you would be paying out the nose for the computation that the Ethereum program, because it's proof of work, you would be paying for doing cryptography over and over and over and over again on 1,000 computers all computing the same thing. So it really doesn't make sense to do Ethereum on top of Rholang. That said, because our current plan involves independent blockchains being clients of each other, you can maintain state about contracts running in an Ethereum blockchain and interact with that as a client, just like you would interact with a different RChain blockchain as a client. So it's conceivable that you could use Ethereum as a node in the RChain network. But we haven't worked out the details of that yet. Well, identity itself, the question was, what do I think about identity on RChain, given that you can create as many as you need? The object capabilities community has, for decades, been pushing the view that identity is rarely, if ever, necessary for doing what you usually want to do. I would highly recommend going and reading the object capabilities literature to get a flavor of that. But just for instance, when you go to the store and pay in cash, nobody cares what your identity is. All they care is that the money you are handing over is legal tender. If you go to the grocery store and sign up for a loyalty card, they don't care about your name per se, just that you present that same card when you go back, right? If it's, say, a coffee shop, they just give you 10 punches and then reward you. They just care about whether you've presented the card or not. With the grocery store, they track your purchases and do correlations on things that you're trying to buy so they can offer you deals and get you to buy more, but they don't particularly care what your name is or so on. I'm sorry, could you repeat that, please? So for self-sovereign identities, that is really managing how much information is shared between different clients of your identity, right? That, but again, each different view of identity, whether it's, I received this message along this channel, and all I know is that it came over that channel, versus here is an attestation from some party that I am relying on to verify certain properties, right? Like in the United States, you have to present your identification in order to go into a bar. The bar relies on the driver's license bureau to check the birth date of the the holder of the card. So then all they have to do is make sure that the face matches the thing on the card, and they check the age. Anytime that you're relying on somebody else to validate something, that's a different notion of identity. The banks, when they issue credit, only care about your transaction history. They don't so much care about other properties of your identity, who your friends are, and so on. They just want to see a bunch of transactions, and they don't even care really about the details of the transactions. They just have some set of rules, and if your set of transactions meets their rule, then you pass and you get approved for credit. So in each of these situations, there are different notions of identity, but I think all of them, insofar as you can code up what you mean, are supportable on RChain. And so we'll be able to support a vast ecosystem of different notions of identity, and it'll be really fun to see how they work with each other. Well, it's really gratifying to see so much interest in this project, to see the growth of the project. We're very grateful for all of you and your time and your loss of sleep coming to spend it here with us. Look forward to future collaboration, and excited to see what you guys build on top of RChain. Thank you. Thanks for having me. See you later.
No problem. So with that, we end the evening. Thank you so much for coming here and spending the time with us. So thank you, and enjoy the night.